Hello and welcome to the second video of the series describing the banking application I have developed. BatBank is a single-page web application developed with the MERN stack. To understand the backend and its interaction with the frontend, I followed a model control view approach. Although strictly speaking MERN doesn't exactly follow that, it is still a good approximation to understand it. The view part has been described in the first video, so here I will focus on the model and controller parts. For the model, I used the cloud-based MongoDB Atlas database, and to define the schemas and queries to the database, I used the object data model in Mongoose. The controller part is the Express web server. Within that controller, the main file is server.js. All the connections parameters, execution settings, and external models required are defined in configuration files that fits into it. Connection to the database is managed by the function in the mongodb.js file. Interactions from the frontend are passed through the middleware function middleware.js, including the JSON web tokens to the API defined in routes. I defined RESTful APIs and separated the router from the callbacks. That made it easier to debug and, if necessary, to modify any function. These calls are then passed into the database by querying the schemas defined in the function schema.js. Although in the first version I defined three different schemas, transactions, user, and accounts, for the scale of this project I later realized it was simpler just to have one collection containing all the information for the accounts and transaction histories. The schema was defined with Mongoose as well as the CRUD queries. The data abstraction layer was separated in routes and callback functions. Not only was easier to debug, but passing the token was also straightforward as they were easily included as an extra argument in the routes call. An important point was how I managed the balance. I did have many options, but the easier for me was to keep it as an entity on each historical transaction, so every time a new transaction happened, a new value is added to the history array. The balance is not an updated variable, but one with multiple instances. The good thing is that I don't need to recalculate the balance every time something happens in the frontend, but if for some reason something happens that makes the value null or a string, it will propagate to any future transaction. Because there were few operation needs, I defined only 8 APIs. The first one is just a testing one to ensure the endpoint is up and running. In following versions, though, this will be used to test the connection to the database itself. Most of the APIs are to get information, such as the historic transaction for certain users, identified by the email in the query, email list to select recipients of transfers, last record to get the current balance, check whether a user exists or not, which is useful when logging with Google accounts, because those cases are treated as login in the front end, so there is no way to know a priori if it is a returning user or a new one. The only post operations are to create new users and to add transactions. Transactions is a generic operation I defined, so the same post will be used for a deposit, a withdrawal, or even a transfer. So it was easier to branch the code based on the transaction type rather than to define different transactions at the collection level. And actually the separation was made mainly at the front-end level, where it was already done through the component itself. So these were the main design criteria for the backend. Now let's jump into the live demo. Thanks.